Hi everyone, you are welcome to my class. In today's class, we are going to look at calculations on radioactivity. For more detail on the topic radioactivity, make sure you watch the videos on the topic on my channel. So, number one question says, in 24 days, a radioactive isotope decreases in mass from 64 gram to 2 gram. What is the half-life of the radioactive material? Half-life, decay constant, the discovery of radioactivity is discussed, well explained on that particular video. So, half-life is the time taken for half the initial number of radioactive element, the atom of radioactive element to decay. Are we clear? And please note that your half-life is always less than time of disintegration. There's a video on the formulas. Make sure you watch that one before coming to this calculation. Solution. In 24 days, it takes 24 days for the radioactive element to disintegrate from the initial mass to the final mass. So that time it takes is known as time of decay. Time of decay. And make sure in a situation where you have the questions to be, they give you time of decay, they also give you half-life, make sure the units are the same. The unit of time can be in minutes, it can be in seconds, it can be in hours, it can be in days, it can be in weeks, it can be in years. Every radioactive element has their respective time of decay and that of half-life. So we use small letter t to represent time of decay. Here is 24 days. From this mass, this is what? Initial mass of atom, which we call N1 and is 64 gram. To the final mass of atom, N2, which is 2 gram. So what is the half-life? Half-life, we use capital letter T to represent half-life. So I'll put question mark because that is what I'm looking for. The next thing to do is to recall my formula. So I have this formula that deals with half-life, which is equal to the time of disintegration or time of decay, small letter t, multiplied by natural log of 2 all over natural log of r. In that video, we said that r is what? Disintegration ratio. I can transform this formula to just be as simple as t multiplied by natural log of 2 is just like you press ln 2 in your calculator, it will give you 0.693 all over the natural log of r. How do we get the r? The disintegration ratio. If you recall, we said that r is equal to N1 all over what? N2. In that case, we have N1 to be 64 all over N2, which is what? 2. They are both in gram. They will cancel each other. The unit will cancel each other. You have 64 divided by 2 to give us 32. So our R is 32. Hence, the half-life is equal to T times 0.693 all over log R will become T is 24 days. 24 multiplied by 0.693 all over log of what? 32. Natural log of 32. I hope we are following. Now all I need to do, multiply 24 by 0.693. That gives us 16.632 all over. Press ln 32. That gives us 3.466 approximately. Then, which implies half-life T is equal to divide 16.632 by 3.466. That will give us approximately 4.8 days. 4.8 days. Number 2, with the options. I want to highlight something, that's why I put the option there. This is a NECO question. The question says a radioactive element has a half-life of 10 seconds. If a sample of the element contains 6.0 times 10 raised to power 23 atoms, calculate the number of atoms that will remain after 30 seconds. Remember in question 1, I told you that your time of disintegration is always bigger than what? Time of half-life. So from that, you should know that your here is your half-life is already stated, and this is your what? Time of disintegration. As usual, let us bring out our data. Solution. So half-life, capital letter T, is given to be 10 seconds. If a sample of the element contains this is what we have initially before disintegration. So that is my word, initial sample. Initial sample of the atoms is equal to, of the element is, that's going to be N1 is equal to 6.0 times 10 raised to power 23 atoms. So, and said calculate the number of atoms that will remain after what? 30 seconds. So T is time of decay is 30 seconds. So I'm looking for what? Final sample. Final sample, which is what? N2. Final sample of the element after 30 seconds. That is N2 is what I'm looking for, question mark. I hope it is clear. So from here, quickly, I'm looking for N2. I have this relationship that time of disintegration ratio is equal to N1 over N2. I told you by the time you familiarize yourself with the formulas, you know which one to put first. But I don't have this. I have this, I'm looking for this, but I don't have R. Is that clear? Then that will quickly remind me that I have this, which say that R is equal to what? 2 raised to power N. You see how I'm relating the formulas? Now, I don't have what? Small letter n, which is known as what? Number of what? Number of disintegration. Is that clear? Remember again that video where the formulas are stated that n is the same thing as time of disintegration all over what? Half-life. You see, these three formulas will solve my problem now. So from here, I have n is equal to what? Time of disintegration is what? 30. I'll write it. Half-life is 10. I'll write it. This implies that number of what? Disintegration is equal to 3. If I've gotten that, then my R, disintegration ratio, which is 2 raised to power n, will become 2 raised to power 3. Are we clear? Which is equal to 8. I hope this place will be enough. When I'm done with that, I'll come back to this place where I have R is equal to N1 all over what? N2. Put the value of R, which is what? 8, is equal to N1 6.0 times 10 raised to power 23 all over what? N2 that I'm looking for. Is that clear? So when I cross multiply, I have 8 multiplied by N2 is equal to 6.0 times 10 raised to power 23. So divide both sides by 8. I have N2 is equal to 6.0 times 10 raised to power 23 all over 8. Doing that will give us 7.5 times 10 raised to power 22, which is what? Option E. But now, if I say this minus this, or this minus this, take away this from this, that is what? Known as number of atom decayed. If you know, remember the formula I have, Nd is equal to what? N1 minus what? N2. Meaning that I'm going to have 6 exponential 23 minus 7.5 exponential 22. That will give me 5.25 times 10 raised to power 23. Now this is it. I have two answers, this one and this one. If you don't know what you are doing, you might get confused in the exam hall, right? So know when the question asks you to find what? Number of atom decayed, or find the final number of atom left after the disintegration. Are we clear? So the correct answer here is what? Is this. E is the correct answer. But if the question says you find what? Number of atom decayed, this is the correct answer. Let's move to number 3. The question says a radioactive sample initially contains N atoms. After 3 half-lives, the number of atoms that have disintegrated is, as usual, bring out your datas. So, initial number of atoms, that is N1 is given to be what? N, just like a value. N can be 20, can be anything. After 3 half-lives, number of half-lives, which is small letter n, is equal to what? 3. Then you're looking for what? Number of atoms decayed, which is this. Remember that I said the formula, the next thing is to recall your formula. You have Nd is equal to what? N1 minus what? N2. The number of atom decayed is the difference between the initial number of atom minus what? Final number of atom. So if we look at it here, how do we get our N2? We have N1, which is N. We don't have N2. So we use R is equal to N1 all over N2. This R is the same thing as 2 raised to power N. By now, I know we are familiar with this formula. So, which implies N1 is N, I'll write it, all over what? Yes, I don't have this N. How do I get it? Is it given? Okay, yes, it's given, which is what? 3. So this shows that I'm going to have N1, which is N, all over what? N2 is equal to what? 2 raised to power 3, which implies that n all over n2 is equal to 8. When you cross multiply, I have 8 multiplied by n2 is equal to what? N. From here, n2 is equal to n all over 8. So I have my n2, I have my n1. I can now go ahead and find what? Number of atom decayed, which is n1 minus n2. So what is my n1? That is n minus n2, n all over what? 8. Make this one over 1. That will be equal to, find the LCM, 8. This will give us what? 8. 8 times n to give us 8n minus 8 in 8. You have what? 1. 1 times what? N. I have what? N. That will be 8 minus 8n minus n to give us what? 7n all over 8.